Hello, can you hear me?
Yes, how are you doing, brother?
Yeah, Alhamdulillah, I'm fine. And how about you?
Good. Alhamdulillah.
Okay, thank you for joining. So basically, today is our first test, and mainly today I will try to discuss about the some thematic mapping. So basically, this type of map we need when you want to make the broad susceptibility mapping. We need this type of thematic mapping. Okay, and how we can easily create this type of map. We also like to discuss. You already send me your study area. Okay, so in this time I just show
Yeah.
you the all of this example from your study area. So it is very better for your understanding. So let's guys simply share my
Mm,
screen.
okay.
Okay, so now can you see my screen? Is it visible or not?
Yeah, I can.
Okay. Okay, so basically today I will try to discuss about that flood susceptibility mapping using GIS-AHP multi-criteria analysis. So basically for this analysis, we have to create some thematic mapping. Okay, so
Mm,
we have to create this type of map such as distance from road map, that says distance from river map. Then we also create this land use land cover map, and also create for that a slope map, elevation map. So these type of things we need to create, such as you can see flood susceptibility criteria and sub criteria range for flood susceptibility assessment. So we have to create the topographic witness index, elevation, land use land cover, slope. Not only for that, I just make the list all of those thematic mapping. In this time, I try to show you that all of those map how we can easily use, and then make the GIS ASP multi-criteria analysis, and then classified the flood susceptibility region. Okay, so here you can say I already write this type of factor. We make the TWI, mainly topographic wetness index, elevation, land use land cover, slope. We also try to discuss about the precipitation, drainage density, as well as also NDVI, distance from river, then distance from road, and soil type. So all of
mm,
those we try to discuss. All of those, these are flood factor. Okay, so in this time it's also called the thematic mapping. Okay, so this type of factor, first of all we need to create. Okay, then we are just mainly we just classify suppose 5 class, and we are just make the suppose this type of susceptibility class very low, low, moderate, high, very high, and also susceptibility class rating. Okay, we also just calculate the rating, and also we put the weighted value for each factor, and then further we are just make the final flood susceptibility mapping. Okay, so in this
yeah.
time we need to create this type of factor. Okay, so today I'll try to show you the some factor how we can easily create. So basically it's our total 5 days online training program, so that's why we have a lot of time. Don't worry about that. We try to complete all of these things properly, so that you can easily learn,
Mm.
you can also try to apply, and also you can practice on yourself,
So,
and you can easily do
are
it.
you
Okay,
recording?
okay, also recorded, no problem. It is recorded. You can also get the recorded video class after completing this live training. You can also get the recorded video
Oh,
class. Okay, all of those
all right,
material,
all right, brother.
PDF slide, you can easily get, no problem. Okay.
All
So
right.
today, first of all, we try to discuss about the our satellite data. Okay. Suppose how I can easily download the satellite data.
Mm-hmm.
So uh, in this time, I just simply go to this website. Mainly, it's the Art Explorer usgs.gov. So basically, this is our this is the website. You can simply go to this website, and first of all, you need to log in. Okay, in this time I already created my account. Okay, so I already created my account. I already you can see this my show Mijanur Rahman 690. So this is my username. You can simply put all of those information, all of those things you can simply put, and then you can easily download it. So now how I can download? So I show you that from the first all of those things. So just I simply search the Google, suppose Art Explorer. Simply search. Okay. Here you can see this is the first website, Art Explorer. So simply go click on here. And this is our user interface. Okay. So in this time, first of all, what can I do? First of all, I need to select my study area, which area I want to download. So I remove that because previous I also download this type of things from the study area. So I simply show the first step, all of those things. Okay. Emitters. Okay. So in this time, first of all, you can see the search criteria. In this time, here you can see you can search the different way. So in this time, I simply click on the KML and shapefile upload. Okay. And here you can get a one option to search. Suppose if you want, you can simply put your KML file or KMZ file, suppose, or shapefile. You can simply select and automatically select your study area. So it's a one process for you can simply select your study area from KML or KMZ file. Simply select your file, no problem. So it's the one criteria. And if you want, you can see geocoder. So in this time here you can see the different types of feature, address and place. I simply click on the address and place. Okay. Then simply search your study area. Okay. So in this time, your study area, mainly this your study area name is that you can see. Mainly it's called the Belly D1E. So this study area, I want to work for that. So I just simply copy the name from here. You can just write your name. Okay. Your study area name. I simply search here. Okay.
Yeah.
So in this time, after every show the map, you can say show, click on here, show. So now you can see it show the address about that your study area. So simply click on here. Okay, so now you can see it select my study area. Suppose basically this city is for this study area. In this time, suppose for this region, I just simply different way. Suppose it is your study area, so you can simply select one study area. Suppose also in here, or if you want, you can also remove. Suppose you can simply remove this type of thing. Simply remove from here. Suppose remove, 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 also remove. So in this time, you can simply suppose put a one. Just make a square shape about that. Suppose this. Suppose this is my study area. Okay. Suppose this is your city. I simply draw my study area. Okay. So further, after doing these things, you can simply go to the data set. Here you can say data set. In this time, suppose I download the DEM data. We need the DEM data for our work. So for the DEM data, click on the digital elevation. Simply click and then go to the SRTM. Here you can see the SRTM. Okay. And for the select this SRTM dataset. Okay. First one SRT, one arc, second global. Select that. And further, you can simply go to the below and you can simply search here. You can just select result. So click on the result. So now it loaded. You can see it loaded two images for your study area. We can get the two images, mainly DEM data. It's a DEM data. So here you can see, I just simply click on the footprint. So in this time, it show about the footprint. So mainly it's covered this study area. Okay. And this is my study area. So I did not use it because this footprint is not cover my study area. So it's the another. Okay. So I check the another image. So simply click on here. So in this time here you can see. Okay. So you can see this footprint or these tiles is fully covered. It's cover my study area. Okay. So I can easily use these tiles. I can easily download these tiles and work with that. Okay. If you want, you can also click on here. You can see the image. So basically click on here. You can see second option, show browse overlay. Click on here. It loaded the image. So click on here. Yeah. So you can see in this time I can get this my DEM data. Okay. So now I have to download it. For downloading this DEM data, simply click on here. You can see download option. Click on here. Here you can see it loaded. So in this time, simply click the download geotip. Okay, download geotip format. Simply download. So then it will be downloaded. I already download this image here. You can see I already download this image for your study area. So basically, yeah, this is the image I download from here. So you can simply click on here, then it will be downloaded for any region. Suppose not only for that, you want to make the analysis for the other region. Same process. Simply search your study area, and then simply download your data. Okay.
So we have to make. I have to make sure the footprint first before I
Yes,
download.
yes, yes. Which footprint cover your region? Then try to download this
Yeah, I
tiles.
understand. Yeah.
Okay. So then further, it's one data I need. I already started the downloading. Another data I want to need for that in this time for this flat susceptibility mapping, we also need about the land use land cover map, as well as we also need to create for, you can see, the NDVI map. Okay, so these two things, land use land cover and NDVI, these two things I also need to download the satellite image, mainly Landsat. We are using here the Landsat. Okay, so for that you can simply, okay, so in this time it's done, simply go to the data set again, and further for the same region I want to need also download for Landsat. So for that you can simply go to this below. So in this time uncheck it, in this time it not need, I need the Landsat image. So further the Landsat image, you can see the Landsat, click on here.
Excuse me, sir.
Yeah,
Please
yeah,
give
please.
me 2 minutes. Yeah.
Okay,
I
no
want
problem.
to
Okay, you can take
open
the
my
time. Okay,
work.
okay, okay.
Okay. Okay, sir. Sorry. Yeah.
Okay, no problem. Okay. Okay. So in this time, I simply click on the Landsat. Okay. And I have to download the Landsat collection 2, level 2. Click on here. And I want to download the Landsat 8.9. So just simply click on here. And doing these things, we also need to select the time. When I download this image, okay, what is the time period? So for doing these things, I simply go to the search criteria. Again, you can see search criteria. And further, I just simply go to the below. Here you can see the date range. Suppose I put the image, I need the image, suppose 1st January, suppose 2023, from suppose December 31, 2023. Okay, this time period. I select all of those images. If you want, you can also choose the specific month also. Suppose January, February, March. You can select the specific month. I take the all of this month. Okay, and then I just simply click on the cloud cover. You can see cloud cover. I choose only for those images, suppose 0 to 5% cloud cover range. Suppose 0 to 5. Okay, this range I want to need this image. Then click to the result. So in this time you can see it loaded and it show me the footprint. First of all, I need to check the footprint. Which footprint is covered by study area? I just download it. So just simply click on here. You can see okay, it show it's covered from this, but this study is not covered. So let me check the another footprint. What's happened? So click on here. It also covered this region, but not this region. Okay, so let me check the another footprint. So click on here. Okay, so mainly this you can see it fully covered. Okay, this footprint, this tiles is fully covered my study area. So that's why I can choose it. And if you want, you can also check the information. Suppose click on here. You can see show metadata. So now it provides me all of this information about this image, such as you can see all of this information. Mainly, you can see data acquired this time period, 17 December 2023, acquisition time period, as well as we can get about the image path and raw information. We get all of this information from here. You can see, as well as we can get. You can see cloud cover land 0%. Okay, so all of this information you can easily get from here. And further, you can simply click on here. You can see download option. Okay, so click on the download option. In this time, it show the all of those band. Basically, you can see in this time level 2 surface reflectance band and level 2 surface temperature band. So basically, in this time, we download the full image. Full image contains total 14 files. It's also contain about the temperature band. Okay, so basically this temperature band we need to make the LST making. So that click on the product option. Here you can see I have to download the full product. Okay, so you can see it's the total 857.72 megabyte. So just click on here, then it will be downloaded. So here I already start the downloading. You can see. So basically in this time my network connection is not good, so it takes some time to downloading. Okay, but you can simply download it from here. The same process from this downloading your satellite image. So in this time we're also working, and I already download the mainly your dem data. Okay, so these two satellite images we download. Okay, so now in this time I just use it in my ArcMap software and create this type of flood factor. Mainly this type of, we can see topographic, witness index, elevation, LULC, slope, as well as also you can see precipitation, drainage density, NDVI map, distance from river map, then distance from road map, soil type. So these type of things I can create. Okay, so let's go. Today I also try to discuss about some factor. So let's go. So in this time, after downloading the image, what can I do? I simply import the image in my ArcMap software. Okay, so for that I simply go to my, you can see this my image which I downloaded. So click on here, you can see this my image I downloaded. So just simply import in my ArcMap software. So simply drag and paste in my ArcMap. So now you can see it will be loaded. And click on the yes.
So this is the DOM data.
Yeah, this is DEM data.
Oh,
Okay, so you can see we download the DEM data for your study area as a tiles. Okay, but in this time we are not working for the whole tiles. We are just working for your study area which you already send me as a shapefile. Okay, so for that I simply import your shapefile also. So your shapefile I download and store it in my local storage. Mainly it is stored in, okay, just I simply open. Okay, just okay. So data. Okay, so this is your boundary shapefile. You already send me. I just simply import. You can say SSP. Simply drag and open it. Okay, so now it's successfully opened. In this time, we can get this type of
this
problem.
is
You can see
the
it's not fully filled
this
up.
one.
You can
Oh, the
see,
shape file.
yeah, you can see the shapefile
Oh,
is not covered. Okay, so I also need this type, this image I need from here. Okay, so this side is not covered because this my study area, but it not fully covered. Okay, so it's just cover for this study area. So for that, in this time I also need to download the image from other tiles. Suppose this tiles, this tiles, this tiles, I need to download and then make the merge. Okay, so for doing these things, you can simply download all of those tiles one by one. So in this time, I already downloaded that image, suppose all of those images. So just I simply import in here. Yeah, elevation, I simply click on here. Okay. Okay, dem. I simply import this dem in here. Yeah. Okay, so just I simply import your dem. Okay. Okay, so in this time you can see this dem mainly fully cover your study area, and this is your study area. Okay, I put the another color, suppose red color boundary. Then you can get
So
this.
this one, the last one you uploaded, the dem data, is it at different tile?
Same dem data, but in this time we create the mosaic. Suppose total 4 tiles we download, and then make the combine. We are just make the connect all of those band mosaic.
I think sorry sir, I think I missed that how to combine.
Okay. So for that we need to, okay. So in this time, for doing these things, we are just use the Google Earth Engine platform. So here you can see this is the Google Earth Engine. So in this time, I just need to upload your shapefile. Okay. So how I can upload? Very easy. Just simply go to the
Yeah,
asset
yeah,
tab. You can see.
I know how to upload that one. You can skip that one. I already create some files here.
Okay. So you can simply go to this your asset tab, and from here you can simply go to the shapefile. Okay. And then simply import all of those files, such as your boundary shape file. You can see mainly you just selected your SSX, SSP, PRJ, and DBF. This 4 file we need. Okay, SSX,
Mm.
SSP, PRJ, and DBF. Then open and then upload. So then it will be uploaded. Okay. So further you can simply import your boundary. You can see this is a boundary. So just simply import, and here you can say I just use the same data, mainly SRTM data, digital elevation model data. So further I just simply export this data. So we use this function to export this data. Then you can see task running, and from here you can see the elevation, run it. So you can easily download the elevation. Okay. So further we are
Oh.
just open it. We can get this type of uh, DEM data. Okay, same
So
DEM
this
data,
one
but
we extracted from Google Earth Engine. Yeah.
yes,
After we upload our shapefile, then we put
yes,
some strip, then we
yes,
can get the dim
yeah.
data from there. Okay, understand.
So I also send you this code link. You can also try to use this code easily. So further, which reason you need, simply import your shapefile, and then you can easily get this DEM data for any region using the same code.
Mm.
Okay.
Yeah,
Suppose this is our
understand.
DEM. Yeah. So this is our DEM data. We can get this type of DEM. You can see. In this time, I just clip this DEM with my study area. So there's a lot of way for clipping, because in this time you can see it shows some this type of background. Okay, so in this time I simply remove this type of black color background. For doing this thing, simply click on the image windows. You can see, and you can see image analysis. Click on the image analysis. Okay, so in this time I work for the DEM. So simply select this DEM, and here you can see option background. Click on the background. So I can see background is automatically removed. Okay, so after importing your DEM data, simply go to the Windows and open the image analysis tab. Then simply select this DEM, and then select the DEM, and then simply click on the background. Then background is automatically removed. So now I can get this DEM only for your study area. Okay, so further you can simply click on here and go to the properties, and you can simply select the different types of color. Suppose I want to show this type of color. So now it represented this type of red color identify about the high elevation. and it's identify about the low elevation, this type of blue color. Okay, so in this time mainly it's our DEM data. We can create it, the DEM data. Okay, so using this DEM we can create lot of flood factor. Okay, suppose basically this elevation data we are use and create this type of flood factor such as topographic wetness index, elevation, then slope, as well as we can also calculate for that drainage density. Okay, so this type of things we can easily calculate from the DEM data. So in this time I talk about that this type of things how we can easily calculate, such as topographic wetness index, then elevation, then slope. Okay, as well as also you can see about that drainage density. Okay, so this type of factor how we can easily calculate from this DEM data. So when I can get when I can get the DEM data, I can easily do it. This type of things. Okay. So now talk about the we took talk about this index. So mainly TWI, topographic wetness index. Okay. So basically, you can see first of all some description about this index. So basically, topographic wetness index, also known as the compound topographic index or CTI. Okay, and it is commonly used to quantify topographic control on hydrological process. Okay, and here you can see this is the formula about that. So first of all, topographic wetness index equal, mainly it is a ln or logarithm ln, total catchment area divided by flow width, then finally divided by 10 slope. Okay, so in this time I will show you that how we can easily create this type of index, mainly topographic wetness index, using the DEM data. So let's go, we try to discuss. So first of all, here you can see this is the step for doing this, calculating the DEM data. So first of all, you need to create the DEM. We already create the DEM. Okay, and now fill DEM, then flow direction, then flow accumulation, then slope in degree, then radians of slope, then 10 slope. After that, flow accumulations scaled, and then TWI. Okay, this we just calculate the TWI. So in this time, we are just follow this algorithm one by one, and then calculated the TWI. Okay, topographic wetness index. So let's go. So for that, I simply open my ArcMap. So this is my DEM. I already downloaded it. So in this time, it's not need. I simply remove that. Okay, remove that. It's not need. Okay. In this time, first of all, I just simply click on the catalog. Okay. Then go to the system toolbox, and here you can see about that a option. Mainly, it's called the hydrological analysis. So here is it. Okay, go to the special analyst toolbox, or you can say hydrology. Okay, hydrology. So click on the hydrology and fill. Okay, you can see first of all we need to calculate the fill DEM. DEM we have to calculate the fill DEM. So just click on the fill, and I simply put the input surface raster. Mainly it's our DEM data. Okay, which I already created. And then go to your specific folder. Suppose I want to put all of those things in my specific folder. Okay, so just I simply open a folder in my proper place. Suppose I want to show it and my folder. Okay, so these things. Okay, so I want to show in the E drive. The important slide, part accessibility. I want to make a new folder in here, and then I put here, suppose thematic map. Okay, so then okay, I put the folder with thematic map. So doing this thing, I simply connect this folder. So click on here and go to this PC and go to the E drive, all important slide, accessibility thematic. Okay, so now it's okay. Then I put the file name, suppose fill. Okay, fill them, and further save it, and then okay. So now it creates the fill. It's working. It's working. Okay, okay, take some problem. Okay, let me try again. There's crack software, so that's some problem some first time. Try again, suppose them. Okay, and doing this thing, simply click on here. Suppose I put this fill them and save it, and now go to the environment. Okay, so environment, in the processing extend, click on here, extend mainly same as your boundary. Okay, so your boundary, select that, and after that okay, and also okay. So now let's check. Okay, so it's again show the problem. So let me check. Okay, so further doing these things. Okay, so first of all I simply go to the special analytics tool, and then go to the extraction. Okay, so extract by marks, click on here, and then input raster, mainly put the name, and input feature I simply select my boundary. Okay, then click to the, I put this name, suppose I put this name as a, suppose dim, then okay. Okay, so now it's create the dim, and I simply remove the previous one, and now further I want to, I think it's some problem about my display or your skin, so that's it. So in this time I simply click on the catalog, and further from here go to the hydrology again, and here you can see the fill, so click on the fill. So mainly fill, I want to fill with my dem data, so dem. Okay, then further I simply go to this and simply put this file name, suppose dem fill, and then save, and further go to the environment, so processing extent, put your boundary same as your boundary layer. Okay, then okay, and then okay. So now it's create, I think create the fill. It again show the problem. So let me check again about that. I simply create a new window. Okay, just I remove all of those things and try to work for that first time, because it's a crack software, so that's why it takes some problem sometime. Open it again.
Yeah. And I think the file destination is also problem. I also sometimes got the problem with the file destination where the file you want to save it there. So it can sometimes be that problematic.
Okay, so now we try again. Suppose I simply open my data. Just import the temp data. And further also import your boundary. Boundary. Okay. So first of all, in this time, I just simply click on the catalog. and go to the system toolbox, and here you can see the special analytics tool. Click on here, and you can simply click on the extract by marks. Simply click on here and simply input raster mainly your dem data which you download, and then further it's just simply feature mainly feature your it's your boundary. Okay, so in this time we use the default folder. So now let's check what's happened or not. Okay, so now it's what you can see. So in this time I simply remove the previous one. So this is my study area, and I simply change the name. Suppose simply click on here, I can easily change the name. Suppose I put the name as a, go to the general, I can put the name, suppose dem. So this is your dem. Apply and okay. So now I can create my dem. So now from this dem we create the field dem. So just simply click on the catalog and then simply go to the hydrology and say fill. So click on here. So input mainly put your dem data, and further click on the environment, processing extent. So mainly it will be just same as your boundary area, and then okay, and also okay. So now let's check what's happened. Okay, done, good. Okay, so now I can get the field name. You can see it's get the field name. I simply rename it, and I put the name, suppose field name. Okay, so we can create the field name. After that, we can check our equation. After creating the field name, we need to create the follow direction. Okay, for the follow direction, what we can do, just simply go to the catalog. You can see the follow direction. Okay, simply select the follow direction. Input surface raster, in this time field name. Simply select the field name, and same process. So in this time, just I put the same default folder. So then okay. So now it create the follow direction. Working. Okay, so it also create the follow reaction. Okay, so just I simply rename it as a follow reaction. Just I simply click on here or double click on here. You can simply you can see layer name. So I put the layer name. It's a follow direction or follow dir. No problem. Then apply, and okay, so we can get the follow direction. Okay, and first after doing these things, you can see we need to calculate the follow accumulation. Okay, so follow accumulation. So for that, you can simply go to follow accumulation. Click on here. Here you can see the follow accumulation. Okay, double click and simply input flow direction. So in this time, input follow direction raster, I already created the follow direction. You can see. Okay, so input follow direction, and then same as then click to the OK. So now it's create the follow accumulation. It working for the follow accumulation. It working? Okay, it took a lot of time.
Yeah.
Yeah, so basically there's a problem for that crack software. It load some left time. It's another problem.
Let's wait for a while. I think it's if we start all over again, it will take another time.
Okay, finally done. Okay, so it's coming. Output about the follow accumulation. Okay, so now further I
Good.
simply click on the properties and put this name, suppose follow account. Okay, and then simply apply and okay. Okay, so we can get this follow accumulation. So you can see We calculated that dem, fill dem, follow direction, follow button. In this time, you can see slope in degree. We need to calculate also. Okay, slope in degree. So let's go for the slope in degree. So for doing these things, you can simply click on here catalog, and we can go to the surface option, surface toolbox. So basically, you can see surface and click on the slope. And basically click on here. Here you can see the fill dem. Okay, we calculate the slope from the fill dem. Click on here. And unit is the degree. Okay, so simply select the degree and then okay. So now it calculated the slope from here. Okay, it is done. Okay, we can get the slope. So just I rename it. Slope. And then apply. And okay. So now after doing the slope, we have to calculate this type of things. Mainly it's called the radians of slope. Okay, radian of slope. And this equation you can see slope multiply with the value and divided by 90. Then we can get the radians of slope. We need to calculate the radians of slope. So for doing these things, I simply go to the ArcMap again and click on here. And in this time, I will just use here the map algebra. Click on here. Here you can say raster calculator. Just simply click on here, raster calculator. So first of all, you can see this is the equation I need to calculate for this time. Slope multiply with that. So for that, I simply take a parenthesis, also parenthesis, and then simply call the slope. Okay, this slope mainly it's multiply with a value. This value is mainly 1.5. So simply copy the value, then divided by 90. Okay, so now I simply go to my calculator and then put here this value. Okay, mainly it's multiply and then divided by 90. Okay, so you can see this equation is simply put in here. So basically this equation is that slope multiply with that number divided by 90, then we can get the radians slope. Okay, radians of slope. So just click to the okay. So now it's calculated the radians slope. Okay, done. So further I simply put the rename, click on the properties and put this radian, then apply. Okay, okay. After doing these things, we are just simply check the another. We can see in this we will calculate about that tan slope. Okay, this is the tan slope formula. We have to just apply for tan slope. Or you can see con. This is our formula. Okay, so I simply go to the ArcMap and click on the map algebra again. Then raster calculator. In this time, I simply find out my. I can see. Yeah, conditional con. Okay, so in this time, first of all, here you can see we have to select the slope. Okay, slope. We already calculated the slope. You can see slope. Mainly it's greater than 0. Okay, and then you can see what is the formula. Then 10 slope. Okay, so comma. Then put here after comma. Simply call the 10. So you can easily get the mathematic and the 10. You can see trigonometry 10. Click on here 10 and 10 mainly slope. Okay, 10 slope. You can simply call the slope. Okay, then comma and put the value. Mainly this value is that 0.001. So 0.00. So now just simply click to the OK. So now it's calculated the 10 slope. Okay, done. It calculates the 10 slope. So just I simply rename it properties and 10 slope. Okay. Then further apply and okay. So we can get the 10 slope. After doing these things, just simply check our formula. In this time, we calculate the flow accumulation scaled. We need to calculate these things. Flow accumulation scaled. Okay. So for doing these things, the simply follow accumulation plus 1 multiply with cell size. Okay. So this formula when I put, then I can get the follow accumulation scaled. So for doing these things, again, simply go to the calculator. You can see the raster calculator. Double click, and here you can see in this time I just apply this formula. This formula is that flow accumulation. So just I simply take a parenthesis, also close the parenthesis, then call the flow accumulation. You can see flow accum. So simply click mainly plus 1. Okay, so simply plus 1, and after that multiply with scale. So here you can see formula multiply with scale, cell size. Okay, mainly multiply cell size, follow accumulation cell size. So simply you can click on here and go to the properties, and you can get it that mainly source. Here I can get the cell size. Okay, so I simply copy the cell size from here, from the full accumulation. Simply copy, and further just simply paste here. Okay, so now I can see this formula I simply put in here. Basically this formula is that flow accumulation plus 1 multiply with cell size. Okay, so now just simply click to the OK. So now it calculate about that your full accumulation is scaled. Okay, so done. So now it calculate about that follow accumulation scale. So just I simply click on here and go to properties and put the name. Suppose it's a follow accumulation scaled. Okay, that I put this name like that. Apply and okay. Okay, so after doing these things in this time, this is our last factor. Mainly, it's called the TWI. Okay, here is the TWI, topographic witness index. Mainly, it's the lawn flow accumulation scale divided by 10 slope. Okay, I already find out all of those flow accumulation scaled, find out the 10 slope. Okay, so now I just simply put this equation and calculated the TWI, topographic witness index. Okay, so let's go. So for doing these things, I simply open this ArcMap and go to the catalog, again map algebra, raster calculator. And then I just simply put the formula. Mainly this formula is that follow accumulation scaled divided by 10 slope. Before that you have to put the lawn. So first of all I take the lawn in here, you can see lawn. Okay, this is the lawn. And then call the your follow accumulation scaled. So basically you can see follow accumulation scaled, mainly this is the follow accumulation scaled divided by formula is that you can see this formula is that 10 slope. So just simply I already calculated the 10 slope, you can see 10 slope. Okay, so now I just simply apply this formula TWI final formula. So now I just get the topographic witness index. Okay, then okay, so now this is our final factor, topographic witness index we calculated. Okay, so now I can see we can get, okay, it created, you can see. Okay, we can get created this type of things from here. So in this time I simply put this, simply go to the properties and it called the TWI, and I set the color, simply go to the display or symbology. Suppose I want to show this type of color, apply and okay, and further it's not need, I simply remove that. So basically this type of layer we create for calculating the TWI. Okay, so in this time we can get the TWI, so that's why in this time it's not need. Okay, so in this time, simply click on here and go to the properties and set the classified. Suppose 5 class, simply select apply and okay. So now you can get these type of things. Okay, and here we can get this type of value. We can see. So basically, this type of value, basically it's mainly okay. You can see in this time here you can see this type of value for the topographic wetness index. When you can get this type of value, suppose very low value, you can see very low value, low, moderate, high, and very high value. So very high value, it's indicating that very high susceptibility class. Okay, suppose when I can get a 3.7, suppose 14, suppose very high. Okay, suppose class rating 5. So this rating identify very high susceptibility of flood, this type of value. Okay, and when I can get the low value, so here you can see this type of low value, it's identify about that your low susceptibility. Okay, so very low susceptibility, then second low, then moderate, high, and very high. Okay, suppose you can see the for the elevation what happened for the high elevation, this rating is very high, mainly for that very high, suppose high, moderate, low, very low. Suppose in this time where the elevation is very high, where the elevation is very low. Okay, for this region flood susceptibility is very high. Okay, and where the elevation is very high, okay, then flood susceptibility is very low for the high elevation. Okay, then suppose low, then moderate, high, and very high. Where the low elevation, we can get the flood susceptibility is very high, and where the high elevation, we got the very low susceptibility mapping. As well as you can see the water body, mainly water body indicate the very high susceptibility of flood for the water body. Agricultural land, then high, settlement moderate, barren land low, vegetation very low. Okay, as well as also in the slope, mainly when I can get the very high slope, very high slope. So that was in the low slope. Okay, you can see very low. Then we can get the result very high susceptibility of the flood, and very high slope we can get the very low susceptibility of flood, as well as the vegetation. So all of those things we try to create look like that. We just create this type of value, and further we are just use it for making the susceptible mapping using the weighted. So in this time, suppose I created for that mainly for the elevation. Okay, so mainly elevation we already created for the elevation. You can see this is our elevation map. So for that, I just simply click on here and go to the properties, and further I set the class. Click on the classified, and total 5 class I simply select, and I choose a color. Suppose I choose this type of color. Okay, I choose another color. So this is an apply. Okay, so you can see we can get this type of color. Basically, this type of color identified with the high region, red color. So this high elevation have low susceptibility of flood, and this low elevation is the high susceptibility of flood. So in this time, suppose we can get the two parameter TWI and also get about that DM. So I simply remove the other parameter. It's not need in this time. So remove. It also not need. Remove. Right? So you can get the two-way TWI and also get about the DEM. So now further, I need the suppose slope. So simply click on here and go to the surface. Here you can see the slope. So here you can see the slope. Click on here. So now simply input raster mainly DEM. We create the slope from the DEM. and in the degree unit. So then okay. So now it's create the slope. Okay, we can get the slope, and in this time we can get only for the two class for your study area, because basically it is a totally flat region. That is not much high region, so that's why in this time we can get the slope. Mainly it's the degree. We can get the 0 and also get the 0 from 89 degree. Between these range we can get, and you can see when I select the 5 class, it's not work because it's not some such much variation about this. Okay, no problem. We just consider it is the 2 class. Suppose 0 is identify about that high flood region, and 89 degree is the low flood susceptibility region. We consider it and then work with that. No problem. Okay. So in this way, we also get about that slope. I change the name. Okay, apply and okay. Okay. So after doing these things, we create the three factor about that, and then we check the another which we can create. So we created for that witness index TWI, and create about the elevation, then create about the slope, okay, then okay. So in this time when you can calculate it, the distance from river and distance from road map, we need the river shapefile, as well as you also need about that road shapefile, okay, for your study area. So for doing these things in this time, I simply show you that how we can download the river and road shapefile, because in this time we need the river shapefile and also need the road shapefile. Okay, so for doing this things, you can simply go to a website. Mainly we can easily download it from here. You can simply go to the diva, this website. We can easily get that. And then further you can simply select your study area, your country. So is it Somalia? Yeah.
Yeah, it's Somalia.
Okay, so just I simply find out the, we can get all of the Somalia river and Somalia road boundary shapefile. So
Actually, there are no many rivers there. We have only two rivers in Somalia, so
okay, so we can check out from here. You can say Somalia. So click on here,
yeah.
and then we download from the road. Okay, first we try the road, and then okay. So now it's download the Somalia road shape file. So just I simply check from here what is the condition about the shape file. Download. Okay, downloaded. You can see. So simply click on here, and these are download. So I simply copy this data and go to my folder where I put your file. Basically, yeah. So this is that. Okay, then let's simply put in here data. We just simply store it in here. So now you can get all of the Somalia road. So just I simply unzip this file. Okay, so this is our okay road shape file. I simply import in here. Then this time I simply uncheck this type of layer. Okay, and I simply import your road shape file. Okay, so now I can get the road shape file for the Somalia, and I need the road shape file only for this study area. Okay, so I need the road shape file only for my study area, which I choose. Okay, so now what can I do? First of all, I need to clip this shape file. Okay, only for my study area. So you can simply go to the geoprocessing. You can check it option, mainly clip option. Click on the clip. In this time, input feature, I simply put the input feature, mainly your boundary, and I need to clip with my study area. So mainly this is your city. Okay, then I simply okay. So now we can get the result only for my study area. So it's clip, you can see. So in this time, I simply remove that. It's not need. I simply remove that. Okay, remove. So now we can get, you can see the SOM. So this is my road for my study area. This type of road I can get. So now I want to create the distance from road map. I can easily create, because when you want to make the distance from road map, we need only for the two parameter. One is the road shapefile, another is that your boundary. Okay, I think I got all of those things. So now go to the catalog and I find out a option, mainly it's called the distance. You can see distance, click on here and click on the Euclidean distance. You can see Euclidean distance, click, double click. Okay, then input raster, input mainly this time input feature. I have to input feature with my road shapefile, and in this time, okay, so then simply put here 30 meter. Okay, because in this time all of those index, land use land cover map, ndvi map, twi map, dem, all of those cell size must be same. Okay, so that's why we have choose the Landsat image, because Landsat is a 30 meter. NASA SRTM it also 30 meter. And when I create the distance from road map, distance from river map, we must use the same pixel area or cell size 30 meter. Okay, so just put here the 30 meter. For that, go to the environment, and further I just simply click on the processing extent, and then put here your boundary shape file, same as your boundary shape file, as well as also go to the below. Here you can see the raster analysis. You can raster analysis. Click on here and marks with your boundary. So click on the here. You can see your boundary or city boundary, and then OK. So in this time, just click the OK. It create the distance from road map with 30 meter pixel, because I put the cell size as a 30 meter. So now let's check what happened. Oh my god, you can get the problem. Okay, I think first of all we need to save the shapefile. Okay, so I simply save it, data, export data, and we export the data frame. Okay, coordinate system as the same with my data frame. Okay, now okay, yes. So now remove the previous one. Okay, I just rename it. Okay, I rename it later, no problem. And then simply go to the Euclidean distance, and then simply put your road shapefile. Again, put the output cell 30 meter, environment, processing extent, mainly your it's your city, and further go to the raster analysis, mainly is marks with your study area, with your this city. Okay, then okay, and also okay. So now let's check what happened. Working. Oh my god. Take the prime. Okay. Okay, so it not work. Equivalent distance not work. So it's another problem. Okay. Okay, so let me check. Okay, so I use the okay, so okay, I just use the same scale and then try again what's happened. Processing extent, it will study area. And go to the below and put here the raster analysis. Marks with our study area. Okay. Also okay. Okay, so now it's working, no problem. Here you can get. So further, you are just uncheck it and simply go to this properties and put this name. It's mainly distance to road. Okay, then go to the symbology. In this time, simply set the class, five class, and you can put any color about that or represent the distance from road map. Okay, so now it's represent about the distance from road map. Okay, because we also need about that thematic map also. Okay, so distance from road map, slope, TWI, DRAM. In this time, we talk about the distance to river. Okay, so now let's go for distance to river. So further, we need the river shape file. So simply back again, and you can simply select here your inland water. So click on the inland water. Okay. So now download. Now let's check from here. So simply okay, copy this file. And paste here. And then simply unzip it. Then water. And then simply import. I check it not need one time. I simply import this shape file. Okay. For this, in this time, we can get, I think it's a river or other water body. I need this water body only for this study area. So further, what can I do? Same process. Go to the geoprocessing and then clip. Further input feature, your water bodies and clip with your study area, your city. And then further go to the then okay, it's also known, right? So now we can just the river only for our study area. Okay, it's done. So now further just simply it remove not need remove that. So now we can get only for this boundary water body, mainly river or other types of tributaries, okay, or tributary we can get in here. So now further I just simply click on here and click on the Euclidean distance because I create the distance to road map. So then click on here and go to the import your river shape file, and then further go to the environment processing extent. I put here the processing extent same as your city boundary, and go to the further. Here you can see the raster analysis. Click on here, and further marks with your study area. So mainly your city, it's a city. Okay, then okay, and also okay. So now it create the map distance to river map. We can generate. Okay, it's create. You can see. So further, I simply it's not here. I assume that's not it. Simply click on here and go to the properties. And further, just simply general. I put the name. It's a distance to river. Okay, symbology. Yeah, I put the five class, and then simply apply. Okay. So now it's created about the distance to river map. Okay, we can create the another thematic map. So now we talk about that density. Okay, so basically in this time, suppose we generate about this map, drainage density. Okay, for the drainage density, mainly we need this type of. Okay, okay. So I already removed that. I need the river shape file also for the drainage density. So just I simply import again because I removed that river. So just I simply import. So basically this is my river, and this river I simply just need for that my study area, which is my city. Okay. So for that, I just simply click on this and click on the clip again. And then further I simply input feature mainly my water bodies, water line, and clip feature with my study area, and then further okay. So now I can get the water bodies or tributary. Okay, so this type of tributary I can get from here. So in this time I simply remove that, it's not need. So remove. So this is my tributary. So now I want to calculate about the density or water density. River. So for that, click on here. Here you can see about the density. So click on the density. So in this time, I calculate the line density. Okay. Basically, this tributary or river, this type of things as a line. Okay. So further, I simply click on the line density, double click, and input polyline feature. So basically, it's my river. I simply select that, this layer. And further, I simply click on the environment and processing extent. Mainly, it's my city. And further go to about that your raster analysis. So here you can see the raster analysis, and then click on your marks. Mainly it's a your study area, and then okay, and also okay. So now you can get the drainage density. Okay. Now it's get the drainage density. So basically you can see this type of density is very high. Okay, and when the density is the high, then flood susceptibility rate is also high. Okay, suppose here you can see this things is that drainage density is very high, so that's why this type of region flood susceptibility is very high, but this type of density is very low, so that's why this type of region is very low susceptibility. So then I simply go to here and go to the properties, general. I put it's a drainage density or river density, and go to the symbology. I take that only for the 5 class, and then further just apply. Okay. Okay, so basically in this time you can see I created the drainage density. So basically this drainage density, when it's high, suppose when I can get the high value of the density, then the flood susceptibility is also high. Okay, and where I can get the low value, it's identify the low susceptibility of flood region. Okay, so we also calculate about, they can see the distance to river map. So basically where distance is very low, suppose this type of region, river distance is very low, because you can see this is the river, and also the river density. So you can see this type of region, river is very close. Okay, so that's why this type of region is very high susceptibility of flood, because this distance is very near to the river. Okay, suppose, so that's why this type of region is very high for flood susceptibility. Then it also far, and this type of region, mainly the distance is very high. You can see this is the distance, it's very high distance. So that's why this type of distance, this type of region, very low susceptibility of the flood region, because this distance is very far from the river. Okay, also you can see we calculate about that distance to road map. Okay, and we can easily get, you can see distance to road map, where in this time we already make the road map. So now where the which road is near to the river, it's flood. Okay, it's show about that. Also you can see calculate the slope, mainly high slope, it's identify about that low susceptibility, and low slope is identify about the high susceptibility of the flood, as well as the TWI, topographic weightage index, and also dam. We already talked about the dam. So basically high elevation, it's very mainly when you can get the high elevation is mainly low susceptibility of the flood, and low elevation is the high susceptibility of the flood. Okay, not only for that, in this time we just only created this step 1 2 3 4 5 6 factor, but in this time we also need to talk about the other factor. Okay, So we created from here, suppose distance to river map, we done, as well as also drainage density, it also done. Distance from road map, it also done, as well as we talk about that slope elevation. Okay, so in this time we talk about the land use land cover, and also NDVI and precipitation. It's very important. So mainly which data set you want to use in this time. Okay, so do you have any precipitation data for this region, such as station wise data? Is it available or not?
No, I don't have that data, sir.
Okay, so for that, I think it also better when you want to do it. Suppose if you have any station wise data, then we can easily make the proper precipitation map. Or otherwise, we have to use at the this type of data. I'll show you that. Suppose uh, mainly if you want, you can use a charts data set. Mainly this data set provide you, it's a globally, but this resolution is not good. It's another problem. Suppose it's, you can see what is the resolution about this data. This data set resolution is very not good. You can see 5566 meter resolution. So this pixel area is very high. So that's why this type of data is not suitable for the small region, because in this time your boundary is very small, not big. But if you want, you can also use the data set, because in this time you have no data set. So that's why you can also use it for
I
this.
think we should try because I think I cannot find that specific data for rainfall analysis. So
Okay, no
I
problem.
will
You
try to
can,
find it.
or
But
if you get it, no problem. Suppose when you can get the station wise data, suppose for this study area you can collect some station wise data, then we are just apply the IDWI or creasing, then we can easily make the precipitation map. Okay, but in this time there is the no data, so for that I think we can easily download the data from this data set. Okay, it's globally available and we can easily use it, but this resolution is not good. Okay, so you can either download it from the study area. Okay, and okay, and what about that? Okay, so I also try. Okay, so basically, okay, so you can see I also download the Landsat image. Basically, this Landsat image we use for that land use land cover classification map, as well as we also use for NDVI map. Okay, so in this time we're also downloading. So that's why I think I also show you this process for the next further class. How we can easily use this image and make the NDVI and also make the land use land cover. Okay, as well as other, you can see also we need to create for the this type of map, mainly soil type map. We also need to download, make, then NDVI, precipitation, and land use land cover. Okay, so this four factor I will show you the further class. In the meantime, you also try to practice for your study area this type of factor. You try to make. Okay, and I hope you can do it. No problem. You can easily do it for your study area. So download the DEM data from here. Okay, I also send you this code link also.
yeah,
So you can also try to download this data from here and use it in the ArcMap software. Okay, and also send you the recorded video class, so that you can easily practice and create this type of factor. Okay.
all right.
Okay, and for the class I'll show you that for mainly land use land cover, how we can easily create NDVI, then precipitation and soil type, this type of factor. Okay, after that we just try to make the ASP method and then find out the flood risk zone.
Inshallah.
Inshallah. Okay.
All right. That
Okay, so
was
I'll send you
fantastic.
that. You also practice. Okay.
Yeah, thank you so much, sir.
Okay,
Inshallah,
thank you.
nice. We will meet
Okay.
again, inshallah.
Okay,
Tomorrow,
and
so
yeah,
tomorrow,
tomorrow is not possible. I also busy, so basically, I will be available from okay 21 20. Okay, 22.
22 is
Okay, is
Monday.
better for me.
Monday.
Yeah, Monday. Yeah, so it's also
Or
better.
Monday evening.
Yeah, Monday
Monday
evening.
evening,
Yes.
9 p.m., right?
Yeah, so it's a little better for me. Okay, 9 p.m.
Yeah, no problem.
Okay, so you'll try to join at the same time, and in the meantime, you'll also try to practice this type of factor which I show you for the today's session. And if there's any problem, then let me know. I also guide you. No problem.
All right. Thank you so much, sir. Have a
Okay,
nice
thank you.
night. Assalamu
Okay,
alaikum.
have a good day. Walaikum assalam. Okay, bye. Okay.
Bye.